What we're looking to do, Jonathan, is not create a supplementary cementitious material and simply replace the fly ash and the blast furnace slag. We're looking at replacing the Portland cement component. Kaolin being a very high in alumina oxides. The amorphous rates are very high in our kaolinites. So we are in the fortunate position to be able to substitute in the cement, in the binder, a much higher degree than what you would otherwise be able to, supplement it with fly ash and the other things.
Green 360 Technologies has reached a key step in its low-carbon cement development strategy, successfully producing high-quality metakaolin from its own kaolin resources and starting commercial-scale concrete trials. Here to discuss these latest milestones is Executive Chairman Aaron Banks. Aaron, it's always good to see you.
Good seeing you again, Jonathan. Thanks for having me.
It's a pleasure. Now, let's talk through this milestone. What does it mean for the company?
It's significant, Jonathan. So a while back, we mentioned that we were wanting to fill out the plant and obviously increase revenues. We've been able to do that year on year since returning it back to nameplate capacity. But we recognise, having 92% market share in the traditional markets, that we had to look abroad and perhaps even include in that, how we could sell more product into the sort of green emerging markets. So we targeted sort of three potential outcomes there. We're looking at currently animal feed, which is a massive market. We're looking at incinerators, where we can line the incinerators with our kaolin, and it captures the sort of the CO2 emissions, which is another one. We've been successful in that. We've landed a few small sales. We have a couple of very large sales looming on that, hopefully to convert those. And then, as you point to, that which we're to speak to today, is the metakaolin. So what it means is, obviously, aside from bolstering, sales, which then feeds down to the bottom line, because our revenue, because the way we're situated over there with our fixed cost scenario, increasing revenues also increases the bottom line. We create a national sort of solution because we're the only producer that has resources on both the East Coast and West Coast to feed into the concrete market. We're looking to make binders, low carbon binders from our kaolin, to service that concrete market, which is enormous. We can safely say that the globe uses enough concrete to pave a 1 metre pathway to the moon and back 9 times. So it's a significant amount of concrete. As a result, we've had industry, all the major players have started reaching out as a basis on the basis of these results. We've had government sort of leaning into us now and inquiring. Everyone's on the same mission to decarbonise the largest industrial polluter on the planet. So in achieving this, as I said, as mentioned previously, it gives us a national solution. So once we crack this nut and we've produced some of these low carbon binders, we have a solution, as opposed to being a regional one, a national one, and of the states that you would look to want to do this in. Western Australia and Victoria, and probably New South Wales would be the states. Queensland having enough, coal and fly ash to service it for another 1,000 odd years. The states that we're in are the states that you'd want to be in for this venture.
You mentioned fly ash there. Can we have a look at how metakaolin actually compares with fly ash and slag in quality and performance?
Yeah, sure, it outperforms it. It's fly ash being an industrial a byproduct of burning the coal. As you can imagine, the coal seams as they appear naturally have massive variability. It's the same as sort of not quite to the same degree as blast furnace slag, so the traditional cementitious replacements. But what we're looking to do, Jonathan, is not create a supplementary cementitious material and simply replace the fly ash and the blast furnace slag. We're looking at replacing the Portland cement component. Kaolin being a very high in alumina oxides. The amorphous rates are very high in our kaolinites. So we are in the fortunate position to be able to substitute in the cement, in the binder, a much higher degree than what you would otherwise be able to, supplement it with fly ash and the other things. So we are looking to make the actual cement itself, as opposed to just providing a product that can partially replace it.
And some of the other benefits as well here is the benefits that it brings to the strength of the concrete and emissions reduction as well.
Yeah, it's a well-known fact that kaolin increases sort of durability, strength. We've seen results already that after a 28-day and 56-day sort of compressive strength test, the kaolin mix design in the cement binders that we're making far outperforms 100% Portland cement mix. So now we just work through the earlier parts of that, which is the workability and the early strength. So they're the tests now that we're doing, fortunately, with our commercial partners that we're blessed to have at Permacast. We work through these sort of in a commercial setting, as opposed to, just knocking them out in a lab. Lots of things can be done in a lab. But being able to do these out on site in a commercial scale and preparing them ready for commercial applications, we get to not only do that, but we also get to see how it behaves and which end-use applications or products we can put them in real time. So we save a lot of time there.
So I just want to touch on Permacast a little bit more. Can you talk me through, I guess, the tests that you're doing with them and the performance that you're looking at?
Yeah, so mainly with Permacast, because they're a precast manufacturer, to them, early strength is what it's about. We need to put the binders and the concrete into a mold and then demold it as quickly as we can, so you can keep that cycle repeating. So that's firstly and foremost is the early strength and its workability. There's little point in creating a binder that takes twice as long to handle and work, because there's false economies there. So we get to work on the workability of the product as well. And then we move into the sort of the compressive strengths and the durability tests ongoing, because they're the sort of metrics that the government and industry buyers, clients of the products will want to see. So doing that in a commercial setting, whilst also being able to in real time choose the end use applications that it's most suitable for, is highly advantageous. It puts us in the driver's seat to deliver this to market in the quickest possible time.
So let's just elaborate on that a little bit more. When do you expect to launch, I guess, that low carbon cement product commercially?
Yeah, look, the first product has been chosen. We believe we're just finalising the studies on that now. Product number 2 and 3, not as far advanced, but we have an idea. We've targeted them. We think we know which ones we're going to roll with. But for the first product, if the stars align, we would hope to have first product to market hopefully by end of calendar year. So we're looking forward to be able to, we have news flow, lots of it coming with these tests, this particular product that we've chosen, how we're going to roll it out, who are the buyers of this product. This particular product has a shortage in the marketplace, so we expect to be able to fill that and be able to hit the ground running with the first product.
Yeah, Aaron, plenty to look forward to, and the end of financial year isn't that far. End of year isn't that far.
End of calendar year. Sorry, Jonathan. End of calendar year, not the end of financial year.
End of calendar year. That's also not that far away.
It's not. It comes very, very quickly.
Yeah. But yeah, we'll speak again as all of this unfolds. And yeah, thanks for your time today.
No worries. Thank you, Jonathan. Appreciate it.